Hello, Leon. It's your Zayde Mason, and
Hi ho, I'm Kermit the Frog.
we are here to talk to you about the ABCs of physics.
Yes, yes, we are. The ABCs of physics.
So, we are going to do this slowly because the last time I did the ABCs of engineering, just getting through three letters took a while, and I have lots of time on my hands since I'm in Australia right now. So, we're going to actually go through this piece by piece, and let's begin. And we'll begin with A is for atom. Ooh, look at that. That's an atom. All things are made of atoms. You and me, and your bed, and your parents, and Mr. Meeseeks, aka Gunter the cat. We're all made of atoms. Everything you see is made of atoms, except the things that you can't see, which is empty space, but we'll talk about that as well. So, atoms are made of protons, and neutrons, and electrons. Um, and they can combine to make molecules. So molecules are the chains of these things put together that make up different substances like skin or wood or metal or whatever else. And when atoms smash together, they create a nuclear reaction. Okay, well let's have a little talk about A is for atom. So for starters, this is the planetary model of an atom. So originally, the thought of atoms was that they were just these giant balls of matter that existed, and I think that was uh, John Dalton came up with that based on the Greek concept of the fundamentals, and they were just what made up everything. And then J.J. Thomson came up with a better concept when he figured out that such a thing as electrons existed. And he came up with what we called the plum pudding model, where there was this large positively charged thing that was an atom, but it had electrons sort of sitting in substance with it. And then, um, sorry, Kermit could probably explain it a little bit better, but
So, uh, after J.J. Thomson in 1904 came up with it, then Ernest Rutherford, not too long afterwards, came up with his sort of different model that we call the nuclear model. Now, the nuclear model is more of the sort of 1950s version where you see these like little orbiting things that make sort of like a star or an asterisk almost with like the electrons orbiting. And then later on in 1913, Niels Bohr came up with his planetary model. And that's where you see this. The A is for atom. Now, this is the planetary model. But then later on, was it Schrodinger or was it? Yeah, it was Schrodinger, not Heisenberg. Came up with the electron cloud version. What is it called? The quantum model. So that has an electron that floats around on the outer shell, or electrons that float on the outer shell. Now, the electrons float around in probability clouds in reality, as opposed to just these little balls that exist physically. They can be treated as little balls of matter, and each one of those things, protons, neutrons, and electrons, are made up of quarks. And quarks form all kinds of things besides protons, neutrons, and electrons. But the matter that we are made out of, is protons, neutrons, and electrons. There are other things like gluons and fermions, and well, actually, electrons are types of fermions. And in fact, actually, electrons are sort of like the Highlander. They can only be one in any given electron shell around any given nucleus. The center of that planetary model is the nucleus. The protons and neutrons are all glued together by weak force or strong force and not gravity. And they are stuck together, and then the electron sort of exists in a probability cloud around it. And another interesting factoid about atoms is the fact that there's just this little teeny tiny center that is the neutrons and the proton, and the probability cloud of electrons that floats around it is actually quite distant. And What you end up with is that everything that you see, yourself and everything else, is 99.9% empty space. So how does anything even touch anything else? Then there's a thing called van der Waals forces, and van der Waals forces are actually like slightly repulsive, or no, sorry, slightly attracted. So as I go to touch Kermit, he's going to touch my nose. See, nose, and I see how I'm touching Kermit's nose, and I'm holding his hand, and we're living peacefully together. Hi, ha. So you touch things. As you go to touch things, you've got an attractive force that is the van der Waals force, and you also have the repulsion of the electrons. The van der Waals force is sort of like a zero-point energy Casimir force, but we don't need to go into that right now. We can talk about that another time. But there's an attraction and an attraction and attraction, and eventually, when you actually touch something, what you're touching is the repulsion of those atoms, and you sense that repulsion. It's an electromagnetic repulsion. Anyway, that's how it works, and that is an atom. And again, this is the planetary model of an atom, but nonetheless, it is a model, and that is the discussion of atoms. So A is for atom, and that is all we have to say about atoms for the day, without going into a 5-hour dissertation on van der Waals forces and different electron shells and the like. So,
we will say bye for now. I love you very much, Leon, and I look forward to our next lesson, which will be B is for black hole, but we'll talk about that next time, okay? Bye. Bye.